So Keith, there's a lot of talk about multi-server and the importance of it, and what our user base and our customers out there are asking for. Let's go into more detail on multi-server and what we get from NMIS 9.
Sure. I mean, multi-server is all about scaling. You can, years ago, I'd always get asked how many nodes per server. And the reason people were asking that question is because their licensing of their products would force them to using a single server. And that's not a good architectural solution. You need to be able to have the number of servers that you need to have to solve the problem that you've got. So for example, multiple security zones, multiple data centers, different parts of the network that you need to be able to reach, that maybe you can't reach them from that one polar. You may need to distribute polars into different parts of your network. So that's one big reason to have multi-server. And you might only want to run 50 nodes on one polar. You might want to run 500 on another polar. You might want to run 10,000 on another polar. So what we do with NMIS 9 is we give you the ability to scale vertically. So you can run many, many nodes on a single server. You'll need to put lots of CPU memory and storage capacity in there, but you can put many, many nodes on a single server, but you can also scale horizontally. So you can add more nodes or more polling servers how you need to. One customer we've got using NMIS 9 in production is actually doing about 500 nodes per server. They decided that was a good balance of the server specs and the performance on their environment. That was sort of their take on their infrastructure. And then they sort of balance out nodes at about 500 nodes per server. You can absolutely run thousands and thousands of nodes on a single server, but if that suits you, right? Because it just depends on how your virtual infrastructure is structured. But that would be the big thing about multi-server, is it lets you build the architecture, the polling architecture, and the reachability, the connectivity. You can make the servers be placed in the network where they need to be placed to reach the devices they have to reach. Another aspect that's really important of the multi-server is the multi-master. So we don't restrict you to having a single polar. You can have single master, you can have multi-masters. So you do the concept of a primary master. So nominally there's a master that is the super master or primary master. And then you have a series of other masters that you can distribute. So for example, one of our customers, many of our customers have multiple data centers around the world. And this particular customer, currently on NMIS 8, but we'll get them over to NMIS 9 very soon. They have a data center in London, one in the east coast of the US and one on the west coast of the US. And they have a master in each of those locations with polars in each of those locations. And you can make each of the masters, so that several polars are in the east coast and the west coast. You can take the master in the east coast and get the data from all of those polars and display it once. So staff on the east coast get a nice, fast user experience talking to the server local to them. The staff on the west coast, they access the master on the west coast and they talk to that server and they get access to the data, and the user experience is nice and fast for them. So you get that ability to not just put the polars where you need to put them, you get to put the masters where you want. And you're not restricted to a single master. You can have multiple masters. And the beautiful thing that our customers are loving with our commercial tools is using what we call a customer portal or a portal master. So they'll take their internet infrastructure, they'll take one of the NMIS masters and put it up into where the internet can be reached from the internet. That master is grabbing data from all the polars it needs to talk to, and then it's presenting data, and it's configured with slightly different authorization settings, and it might be using a different user system. And then their customers come into that portal master and they can access the servers. They don't need to come through the firewall. They just come into that single master. No traffic from the user ever crosses over to the devices themselves or the polars. They never touch the polars. They only ever talk to the master. And that's possible with OPH 8.3 and NMIS 9. It's just a fantastic capability to have these incredibly flexible architectures to meet what you need to do, and also on the technical constraints that you might have around capacity of your servers, where you've got capacity for polling servers, where you've got a general capacity. I could go on with a bunch of other stuff, but I think that's a good amount.
So I hear you often talk about flexibility of architecture, and obviously from a scalability standpoint as well. But what does it take a typical customer to onboard themselves? Like, how easy is this for a customer to consume this and get it up and running?
Yeah, I mean, you can take an NMIS 9 VM and 8 gigs of RAM is probably a good idea. You could probably do it on less, but really 8 gigs of RAM is not a lot of memory these days. So 8 gigs of RAM and, 2 to 4 CPUs, depending how many nodes you want to run. And you can just spin up a VM in your virtual infrastructure, depending how many nodes you want to do will depend on your disk, but 100 gig of disk, 2 CPUs and 8 gigs of RAM will get you a pretty responsive machine. Add a few more CPUs to make it more responsive. Add a bit more disk if you want to poll more nodes. And probably the only real caveat is you need to make sure that the storage that you're using just has enough performance to match how much data you want to collect. You don't need, NMIS itself doesn't use a lot of, NMIS itself almost has no overhead. All of the overhead is the nodes that it polls. The more nodes you poll, the more data it has to collect, the more data it has to write to the disk. So yeah, like getting that storage performance, read, write, IOPS correct is just probably the only other thing. And for a small network, you don't need a lot of IOPS. You're probably less than 100 IOPS would do you for a couple of hundred nodes.